Okay, welcome to our webinar on earthquake monitoring systems. I am Maria Limoni, Sales Manager here at ICP-DAS USA. I also have Robert Morau, one of our technical support engineers, here with me to help answer questions. If you have any questions, please enter them into the chat box at any time. We will be here to answer your questions at the end of the training session. After we answer your questions, there will be some trivia questions. Please type your answers into the chat box, and the top two people that enter in the most correct answers first will each win $25. An earthquake warning system consists of accelerometers, communication equipment, computers, controllers, and alarms that provide real-time notification about earthquakes that have potential for damage. Seismic switches acquire seismic activity through MEMS accelerometers, which measure the force of acceleration. SAR-713 is a seismic recorder device with a triaxial accelerometer, which helps to detect earthquakes. It has a built-in algorithm which can eliminate non-earthquake vibrations, making it more reliable. It has digital outputs that can be triggered for the emergency shutoff of gas and water valves and other equipment for protection of property. WinPack and ViewPack are programmable automation controllers that can be used for sending alarms, retrieving data, controlling systems, and for automating processes. They have FTP servers for sending and receiving files, and HTTP servers for publishing web pages. ViewPack has a touchscreen interface and a rubber keypad that can be used to display information. Today we will introduce earthquakes, seismic recorder switches, earthquake monitoring equipment, earthquake monitoring applications, and SCADA systems. Earthquakes are releases of energy in the Earth's crust, which create seismic waves. Earthquakes are caused by sliding along earthquake faults. Earthquakes are measured with seismometers, which provide information through vibration signals. Seismic scales calculate the severity of earthquakes, which are described by magnitude and intensity. Earthquakes happen suddenly and sometimes cause destruction, including fires, road and bridge damage, collapsed buildings. Earthquake monitoring systems can help prevent further damage and can help to alert personnel about seismic activity. Seismic switches can be used to alert drivers on a bridge about bridge destruction, so people will know a bridge is unsafe to cross through programmable controllers and web-based LED displays. They can also help notify train operators to stop a train in case of seismic danger. They can also be used to stop elevators, shut off gas valves, start generators, stop plane landings and takeoffs at airports, and to notify fire stations about earthquake activity. This seismic monitoring image shows the latest earthquakes worldwide and also shows past earthquakes. The larger the diameter of the circle, the larger the magnitude. The red circles indicate the earthquakes happened today. The orange ones happened yesterday. Yellow indicates what happened within the last 2 weeks. The pink ones happened in the last 5 years. Alaska, California, Hawaii, Nevada, and Washington are the states with the most earthquakes. The number of earthquakes in Alaska account for more than half of all the earthquakes in the U.S. This image shows the states with the most earthquakes. The western half of the U.S. has more quakes than the eastern half. Some states haven't had any earthquakes in 30 years. Earthquakes centered in one state may produce damage in another. SAR-713 is a seismic alarm recorder with metal casing and is communicable over Modbus RTU and Modbus TCP. It supports operating temperatures between -25 to 75 degrees Celsius or -13 to 167 degrees Fahrenheit. It can be mounted outside in a control panel and is designed to survive in harsh conditions. It can display earthquake data in real time along with maximum intensity and acceleration. It can be synced up with a NTP network time protocol server for clock synchronization with 1-second accuracy. It communicates over Modbus. It can easily be used with HMIs, PCs, PLCs, and SCADA systems. It has 2 digital outputs, so you can shut machines and equipment off in case of earthquake. Modbus function code 1 allows for the reading of a coil status, which is either 1 or 0, on or off. Function code 2 allows for the on-off status of input status. Function code 3 requests the content of analog output holding registers. Function code 6 is for writing the contents of an analog output holding register. Modbus function code 16 allows for the writing of the contents of analog output holding registers. We developed the firmware for SAR 713, so if you need a modification of the product, we can likely change it for you. SAR 713 can log 64 megabytes of data. It will receive a 0 to 40 Hz vibration for any wave. There are 111 parameters of information that can be shown in the SAR 713 utility, including network address settings, DHCP settings, IP filter ranges, intensity degree value, Modbus TCP connections, the counts of earthquake events, and maximum intensity and earthquake event time. Seismic switches can be networked together over the Internet through Ethernet cabling. Many can be installed and the data can be collected by early earthquake warning servers. Early earthquake warning systems through seismic networks can detect moderate to large earthquakes almost instantly, so warnings can be sent before destructive seismic waves reach locations outside the area where an earthquake originates. These warnings allow people to take protective action and can trigger automatic responses to safeguard critical infrastructure. You can also use industrial touchscreen HMIs to see the status of seismic activity and digital output status, so you can see things like if a valve was closed on a propane tank. The intensity of the seismic activity will read higher near the epicenter of the earthquake. You can see here the intensity of the earthquake is 5 near the epicenter, and as you get farther away from the epicenter, the intensity decreases to a 3. Seismic switches are being used for high-speed railway applications. Networks of seismic sensors are installed along the rail route to detect earthquakes and dangerous conditions. In case of dangerous situations, the deceleration or the stopping of trains in affected areas ensures passenger and train safety. The SAR 713 Modbus-based seismic recorders are attached to GT540 cellular-based Modbus device servers. The data gets passed back over the cellular network to a control center. SMS text messages are sent out to alert proper personnel. Seismic recorders are also being used in building earthquake warning systems. They are installed on different floors of a building to monitor seismic activity. They are networked together over Ethernet cabling. In case of earthquake, a series of automated events will be triggered, including lights for visual alerts, the shutting off of gas and water main valves to prevent fire and water damage, preventing accidents in operating rooms, and the shutting down of industrial processes. In factories, earthquake emergency warning systems shut down machinery and heavy equipment in cases of moderate to large earthquakes. Gas valves are shut off. Access control systems are deactivated. Alarms are sent to emergency responders as needed. Seismic recordings are gathered in a report to determine that amount of seismic energy absorbed by the facility. Data from the seismic recorders gets sent back wirelessly over RF networks with SST2450 RF modems to WP8431 WinPack programmable automation controllers, which automate the system. The data then gets sent and is logged in a database and is used along with SCADA control and monitoring software and local HMIs. In bridge emergency warning systems, seismic switches or strain gauge modules are installed along bridges and are networked together over Ethernet cabling to G4500 cellular-based programmable controllers. In case of earthquake or damage, messages are sent out from the controller to web-based LED displays, which inform drivers about hazardous conditions. SMS text messages are sent out to proper personnel so they can address the situation, block off, and repair the bridge. SCADA software is used for displaying vast amounts of data in a simple way through a graphical user interface. It is used for control and monitoring of applications of all sizes. You can use it to generate reports better with queried earthquake activity logged in a database over time. You can use it to display the status of the location of a train and the status of conditions of a railroad with GT540 cellular device servers. You can use SCADA software to show web camera footage through the software. It can be used to send email alarms out based on conditions and the status of industrial processes and much more. You can use it with SAR713 through the Modbus driver. It comes with many other drivers for interfacing with a wide variety of PLCs, data acquisition, and industrial instrumentation equipment. We provide Indusoft SCADA software and can also provide training classes and programming services if needed. Some licenses come with an hour of free web-based training that we can cater around your project. At this time, if you have any questions, please enter them into the chat box. Okay, if there's no questions, then we'll go ahead and move on to our trivia questions. The first trivia question is, what kind of things does a seismic recorder store? What kind of things does a seismic recorder store? Just go ahead and type your responses into the chat box. The next question is, what kind of application can you use a seismic recorder like SAR713 for? What kind of application can you use a seismic recorder like SAR713 for? The next question is, what does EEW mean? What does EEW mean? The last question is, what U.S. state has the most earthquakes? Well, thank you so much for attending our training today. If you have any questions at any time, please feel free to contact us. We do provide free technical support, and thanks again for attending our training.